Alrighty, good afternoon everyone. Thank you guys for taking the time and being here today. So my position at Comfortech Building Performance Solutions, which was a merge of two companies middle of last year, so we're the merge of Tasman Pink Bats and Foreman Building Systems. So prior to being called Comfortech as of July 1 last year, I was working for Foreman Building Systems and had done previously for about 7 years. Passive fire protection for myself is I'm very passionate about it. I worked many years ago, probably about 10 years ago, with a colleague from a fibre cement distributor company that unfortunately got diagnosed with terminal cancer and passed away within 3 months. But one thing he taught me was to definitely make a difference in the industry, and his passion was passive fire. So I had the challenge of working alongside him for a very short time, trying to gather every bit of information that I could and what he knew about passive fire protection, and it kind of just gave me that determination to really carry on. And as many of you would have seen, and as it has been noted previously today by other presenters, passive fire protection has come a long way in the last few years. Still got a bit to go, but we definitely need to congratulate ourselves on how far we have come in a reasonably short space of time. I'm going to start back to the basics, so sorry if you guys are going to start rolling your eyes going, oh, we know what an FRR is. So just going through a fire resistance rating, obviously the three criteria are very specific. They hold their own reasons for being used. The numbers are referenced to minutes, usually go up in increments of about 30 minutes, so 30, 60, 90, 120, 180 and 240. Your first number is your structural adequacy, your centre number is your integrity, and your end number is insulation criteria. Not to be confused with fluff insulation, which you'll be surprised how many people think that in the industry. So structural adequacy is your first number, so it's all about making sure that the element, whether it be structural steel protection, a load-bearing wall or a load-bearing floor, is going to hold up under fire for that prescribed amount of time. Integrity is as simple as any fissures, gaps, openings that are going to be caused in your separating element, whether that be a wall, floor, ceiling. So an integrity seal is your centre number. And insulation criteria is your end number. So insulation criteria in the New Zealand market is often overlooked due to our building code. Fire engineers are able to either reduce or waiver insulation criteria. If I can reference Australia quickly, Australia, not only are they a higher FRR market, so they sort of start around that 2 hours, they always have to involve insulation criteria. So where it becomes important, insulation criteria is about virtually the heat transfer to the unexposed side. So where the fire's situated in this diagram, the unexposed side of that wall needs to stay below 180 degrees plus ambient. So when we mount on a fire test, there'll be a series of thermocouples at certain areas, which is dictated by the standard we're testing to, and that all references making sure that it stops that transfer of heat, whether it be a wall or a floor system, and it even goes into penetration seals as well. So you've got the likes of steel pipes, as you can imagine, they conduct heat through the wall. A lot of the time in New Zealand, we're working to an integrity-only specification, so we don't have to worry about insulation criteria. But in reality of a fire happening in a room, if we're working to integrity only, there won't be any gaps or fissures open for that fire to get through, but that pipe can conduct heat and actually start a fire in the following room without the actual flame being there. It can start purely from heat. So it's a very important criteria that, like I said, just due to our code and the way we do things in New Zealand, it's a bit different, but it is starting to be recognised, and people are starting to sort of upskill and use insulation criteria more, even if it's not required. It is being thought about. So we'll go into some products. So at Comfortech, I look after 99% of my range is Promat. Promat are a global provider for passive fire protection. We work closely with Australia, so all the passive fire products, fire stopping, sealants, collars and the like all come out of and manufactured in Adelaide, Australia. The likes of their boards come out of Belgium and China, and we have a variety of solutions, and I'll work into a couple of other manufacturers that we work alongside as well at the end of the presentation. So we'll work into fire stopping penetrations and seals, so we'll go into some products that is used in the industry. One important thing to note when we're working with combustible services, floor waste collars. Can anyone sort of say why the difference between a floor waste and a stack? it's Ōtautahi. No, so that a floor waste, as the image illustrates, is an open grate at tile level. So any open grate, it could be a laundry overflow, it could be a tiled shower in a bathroom. Any open grate at tile level needs to have a specific fire test for a floor waste. So it identifies where the thermocouples need to be during a test, which are different to a standard stack pipe that goes above a slab in a test. So a floor waste collar for us at Promat looks different. It's got a sort of a fiberglass skirt that hangs down from it, and it's also got a loaded 3/4 spring held to the edge of the collar that's held by plastic cable ties. Obviously in a fire they're going to melt, it collapses the spring. The spring only assists with the closing of the pipe or the disappearance of your plastic pipe. It will not assist with the intermittent building faster. That still has its normal rate, but with that pipe being sort of forced to remove quicker with the assistance of the spring, it allows that intermittent to have the best shot at closing as quick as it can. So the difference between a 100mm floor waste collar and a 100mm conventional collar that would use on standard stack work is about 3.5 minutes for a floor waste and about 7 minutes for a standard collar. Obviously both passing and achieving what they need to in the test, but that's sort of the difference we're working to. So stack collars, we do a range of collars in the industry. So we have a lot of retrofit for New Zealand. We're a retrofit market. We've got stainless steel collars. The coil collar you see at the top there is our Promat uni collar. It comes in a box. The installers appreciate it. We've been able to make different size collars out of one kit. The blue powder coated collars, we've got a square based. So that's for your standard stack work, as the illustration at the middle there shows. So just a single layer plastic pipe. It can be PVC, HDPE. The testing will determine what we've got for that. The circular base isn't just a different flange. It is confused in a lot. People thinking if they've got limitation between clearances of services that they can use the circular base just because it's less of a flange. The circular base is actually for sockets. So it's designed and tested. It's got a larger internal diameter to fit around, say, a 40mm PVC with a 40mm joiner. So obviously your OD of that pipe's going to be a lot larger. And that's what that collar's designed for. So both look very similar, just different flanges that sets them apart in testing. We've got wall collars, so the cylinder collar, like a sleeve that goes through the wall. We've also modified them for some of our ComFloor testing we've done, so we've added tabs onto them and dropped them down through the ComFloor slab. They all are very specific to combustible services. Dependent on testing, we do have a couple of sort of ad hoc tests that allow us to use collars with copper pipes and lagging, combustible lagging, but it's very important to note testing and test assessments is what you're looking for in the industry. Bits of paper and glossy brochures are great, but that's not really, that's not the evidence that the product works. So test reports is what I would stress to you guys to make sure you do have a copy of. A fire collar and how it works. So I'll go through this, hopefully it should start, otherwise I'll click the button again. Oh, there we go. So as it currently shows, this is going to be inside the furnace. So you can see both pipes have a cap on them. It's going to flip around. So now the furnace is on the back side of this wall. The clock is lapsing, so it's not real time. And there is a collar on the left-hand pipe, front and back, so inside the furnace and on the unexposed side, and there's absolutely nothing on the pipe on the right apart from the end cap. So you can see the intermittent on the furnace side collar starting to grow over. So the purpose of a fire collar, depending, I don't like to try and be too sort of cocky when I say this because it depends on how you've been taught, to be honest, but the way Promat's always educated me is that collars don't crush pipes. There's a lot in the industry that they say collars crush pipes for different reasons, and like I say, everyone's entitled to their opinion. I've always been taught that a collar will close over a pipe that has left a gap virtually. So we need that pipe to disappear for the collar to actually do its job. So the pipe on the right now that had no protection, you can see an integrity fail at the wall at the top, and we're roughly about 6 minutes in. So plastics behave in different ways. PVC and HDPE are sort of our two standard plastics that we use. They perform relatively similar in the event of a fire, disappear reasonably quick dependent on the wall thicknesses of them. The difference between a plumbing PVC versus a stormwater PVC versus an HVAC air ventilation PVC, the wall thicknesses are all very different. There is such a thing as a pipe disappearing far too quick, so there is a happy medium. Plumbing PVC performs perfectly for what we need it to do, but again, if someone's asking you to put a collar around a PVC duct that's carrying ventilation and airflow, just be aware we will have to dive into what's the wall thicknesses of pipes and things like that to make sure that there would be testing to front that up. On the second of that, collars wouldn't do that job. We don't test collars to the section of the standard for ventilation, so that's the dampers and grills, so you'd move across to them. So as I said, plastics perform in all different ways, so the plastic is really important. We have to test virtually every size or get a sizes assessed as per the lab, and also go through and do every single plastic through majority of substrates as well. Other fire stopping products that Promat have in the industry, so we have the bulkhead bat, the iconic bat that everyone sees in the industry. Most manufacturers have them, it's just testing that sets us all apart. In terms of product, it's brilliant for those apertures where you guys have turned up to site, and I always say that the passive fire installers are like the ambulance at the bottom of the cliff because they turn up, and unless some of those meetings have happened earlier on, they've usually been given an absolute conundrum to try and deal with. So I take my hat off to them. But in terms of the bat, it is good for those apertures where you do have multiple services running through, obviously still very confined by tested solutions. So we're not saying everything can go through it. We will have test reports for different things. Pillows in the New Zealand market aren't really used. Pillows have always been looked at previously as a temporary solution for some reason. In Australia, they're heavily used. They are a permanent solution, but again, it's just the it's just how they've been addressed in New Zealand and why they're not really preferred here. Promat mortar. So mortar is a lightweight fire-rated concrete, great for backfilling oversized core holes and the like, and there's data to show that we can put collars to the underside. So that's suitable again for those apertures if we're trying to separate floor levels in rises, and working with combustible and non-combustible services as well. The Promat IBS backing rod here on the left, so the green backing rod is virtually a fire-rated backing rod. We can use non-fire-rated or fire-rated sealant over the top of it, so it's for the likes of linear gap seals. It's been tested in masonry, plasterboard and CLT panels as well. So it is a good product to just know in the back of your mind for oversized gaps. Again, limitations on testing, so I sort of sound like I'm saying it's, all these products can be used everywhere. There's always going to be limitations, but just so you can have an idea on their applications. Promat Fire Strip is it's a movement product, it's not a seismic product. Commonly used in, again, linear gaps, control joints. It's compressive one way, so it's fitted under compression, and obviously in a small movement of the building, it will expand out and squish condense down to a size as well. The fire strip's a common product that we specify for your curtain wall details, so where you've got the edge of slab into glazing or window mullions. Essentially, again, as per the fire design, you've had an imaginary dotted fire line literally drawn on your plan of that you have to extend your passive fire to the glazing. Reality is whatever product you put in there is only going to last as long as your glazing, which in New Zealand we don't use a lot of fire-rated glass, which could be minutes. So as soon as that glazing's removed, it was as good as the product trying to hold it there, but that's the product we would use in that application, and it's very commonly, it's pretty much the only thing used in Australia as well. Promat acrylic sealant, so that's our water-based acrylic sealant, hand in hand with most other passive fire products that we have, goes alongside our boards, goes as smoke seals behind our collars. Being water-based acrylic, we do have cable bundles. That is our go-to sealant for our Promat range. It's not intumescent, but we've got all the testing to back it up in terms of cable bunches and the like. We do recently, Promat launched, I say we, I do work for Comfortech, not Promat, sorry, but I feel like I should work for Promat. We have just launched a Promat AG sealant a couple of years ago as per a commercial decision. Promat are a collar company, however, so we have kept the testing to sort of a minimal, more with your PEX and PEX-AL, PEX pipes for your Promat AG for our intermescent sealant. The FlexiWrap is purely, the centre product is purely for your aircon guys, really, and large commercial projects running, very common in Australia, they'll run a tray foil of lagged copper piping. Over here, it still has its purpose in our commercial world, so it is a good product to know about. And the Promat Super Wrap, so the Super Wrap is purely a foil-faced rock wool insulation blanket. That product there, in conjunction with another fire-stopping product of Promat's, will provide you insulation criteria on your services. So whether it be a copper pipe, a steel purlin going through a wall, a cable tray, the Promat Super Wrap is the product we use to wrap a certain distance, dependent on the size of the service and what the test says, and that allows us to achieve our insulation criteria. So we'll move into compartmentation. So obviously the purpose of passive fire in a building is to create those fire cells and reduce that spread of flame. Promat also do a range of fire-rated boards as well. So we have steel stud and timber stud wall systems that we have boards available for. In terms of what we call newer generation boards, we are able to provide up to a 2-hour fire rating with just board either side of a frame without any mineral wool or other insulation in the wall cavity. So what it allows is the architects to then detail if they're an IT wall and they need thermal or acoustic properties, that entire, say, a 90mm timber stud is now able to be used with whatever insulation they need for those other properties rather than taken up with the fire insulation. The system on the right-hand side to you guys, solid partitions, this is a system that's really popular in New Zealand. Plasterboard, we have a lot of one-way systems available in New Zealand via plasterboard. This, I guess, would be our equivalent to a one-way system. It can be built from one side. We do have height restrictions for it though, but it's essentially 2 layers of board for 60 minutes and 2 hours at different thicknesses, staggered joint on a perimeter picture frame. So it is a good system where had actually a hospital entranceway. The ambulance stock moved the double fire doors over and they just wanted to virtually plug the gap. So they built this wall here, which was unpenetrated and had no fire doors in it, and it was definitely cost effective. Fire-rated ceilings and floors. So a fire-rated ceiling, we can do fire attack from the underside, your conventional, with your conventional sort of steel stud. We also do fire attack from both sides, 2 ways, above and below. Timber floor protection in the New Zealand market is commonly used for our balconies or our fire separations on the outside of a building. So Promat quite often gets called up with our boards being able to be used outside. And it's essentially putting a Promat board to the underside of a timber joist, but we do take into consideration the size of the joist and the flooring on top as well as part of the entire tested system. But definitely where that system's used is on those balconies. And there is a load-bearing floor ceiling system that Promat have as well. It's using a couple of their products, Promat System Floor and also Promat 100, where it is a load-bearing structural floor ceiling, fire attack 2-way. So if we're doing a lot of lightweight construction. Recently, at the end of last year, there was 2 modular hospitals done in Melbourne. So my country manager, Steve Fowler from Promat, was heavily involved in that project. And they virtually had the system floor panelling as all the lightweight floor separations. They had another board, Promat 250, as all their structural steel protection, and they had Promat 100 as all their walls and ceilings as well. So the hospital's virtually encased in Promat fire cells. Fire-rated ductwork. So from Promat we have board encasement. Traditionally in New Zealand we use a lot of wraps. For our industry and for what our building code accepts, wraps are definitely still a feasible option in terms of layers and cost effectiveness. However, if we do move into sort of foreseen the 2014 version of the AS 1530 Part 4 test standard, we will be probably moving away from wraps and into other methods. Just with the couple of changes to the code and to the standard, it's actually meant that due to thermocouple placements for failure in testing, wraps have gone from 2 layers to 4 layers to achieve the same result. So we haven't enforced that in New Zealand yet. We can still work to 2005, so wraps are definitely still an option. But for you guys just to have in the back of your minds, Promat do the board or the spray systems where we can make ducts out of board themselves, or we can post-clad ducts as well. Structural steel protection. So I'll start off with structural steel. So Promat do have all 3 methods of protection to protect structural steel protection. So they do intermescent paint, they do board and casing, and they also do your vermiculite spray. So I'm not biased when it comes to presenting about structural steel protection, but I have just limited it to board for this presentation. So board encasement is something that is becoming more popular in the New Zealand market. I always explain it that structural steel protection, there's protection methods that are horses for courses. You know, in New Zealand we use 90% sort of intermescent paint. It's how we've done it for many years. But in terms of knowing the limitations and then also working with 2 other protection methods, there's ways to get around a lot of challenges when it comes to buildability. So we've got 2 products in the market. Promatech 250 is our go-to for up to 2 hours. We do have now some new 3-hour data we can use to encase steel with it. And we also have Promatech L, which is our 3 and 4 hour structural steel protection board. We don't need air gaps to be able to clad our members. Air gaps can be created, obviously, as you see in the channel fix on the bottom right hand side, but that's just a method of install. You can also do the edge fix as it shows above, which is just hard around your steel member. In the New Zealand market, obviously we're working to a 30-60 minute market, so 60-minute FRR based on that we can go up to an HP over A section factor of 300. We're working right down to sort of 4mm hollow sections that we can clad with 15mm board 460-. Cavity barriers. So I mentioned that there were a couple of other brands other than Promat that we have as part of our pacifier package at Comfortech. So cavity barriers, we support the Tenmat brand. So Tenmat is based out of the UK. It is been one of the leading ventilated cavity barrier manufacturers for a while now. So there are multiple products that you can choose dependent on your building requirement. We have what I call the old Wrigley's chewing gum packet on the top right hand side, which is the FF102-25 and 50. So in the name it tells you that the -25 is up to a 25mm cavity and the -50 is up to a 50mm cavity. We also do the Tenmat VFB Plus here on the left, so in the red wrapper, which section view is virtually the same foil strip with intermescent but with a rock wool backing. So that product can go from a 70mm cavity right up to 500mm, and it's manufactured to size. For a vertical application, so when the barriers are installed, they're always on a vertical plane. However, for vertical being into tenancy, so side by side, we would use our Tenmat NVFB barrier. So that is a non-ventilated, so it doesn't allow ventilation through, but that's what our testing is for that application. The other 2 foil strips and the VFB Plus are used on a vertical plane but horizontally, so it would be between levels 1 and 2. And to put that in illustration, you can see here the foil strip just above the window line, and then a little bit exaggerated, but in the event of a fire, obviously it expands out and closes off the cavity. And to back that up, we also do another brand called TBA Firefly. So out of the Firefly range, we carry the 2 flexible curtains that are able to do seismic applications. So between walls or a seismic gap in a floor, we're able to use the Firefly material, which is virtually a lightweight combination of a high temperature woven fabric and what we call foil packets. So it's a glass wool with tin foil virtually, but as a solid product. We do one for 30 minutes and one for 60 minutes, and we can apply them in these seismic applications as per the test. So they are a good one to know about if you've got any. Obviously in New Zealand we've got to create buildings to seismic, hence why Promat don't do a lot of seismic stuff out of Australia, so yeah, we've teamed with TBA to be able to offer that in the industry. And that's myself, so I appreciate your time. Thank you. Thank you.